Thank you, Jim, for that amazing introduction, and thank you everybody for being here this morning. I'm going to take a lot of sips of water because I usually go very dry throat here. But I'm Bill Limpisathian, and I have the distinct honor of kicking off the first session, or one of the first presentation at the main conference, and it is essentially going to be a little bit of a research agenda setting piece. I just started at the UW Madison Department of Geography back in January, so I've been there 10 months now, 2 semesters and 1 summer. So as I'm starting to evolve my existing research and start an agenda and try to plan out a research group at UW Madison. So I just wanted to take the time to talk a little bit about it, because I definitely think it's super interesting and awesome. But before I do, let me just do a quick land acknowledgement that the work I do at the University of Wisconsin-Madison happens on land occupied by that has historically been home to the Ho-Chunk Nation, and that today we are presenting in the ancestral home of the Seneca, the Dina, the Hopewell, and the Monongahela peoples. And with that, we'll get started. Okay, I'm going to make it a little interactive at first. I'm going to ask everybody to sort of close your eyes, just quickly, just a quick exercise. And now, quickly, think of an apple. And then you can open your eyes, but make a mental note of that apple. And I'm going to ask you, how vivid was that apple? Was that apple crisp? Did you see a Granny Smith? Can you imagine the shine on that apple? Was there a leaf, was there a stem, or was it more of a conceptual apple? Or maybe there was an apple in your mind at all. What I essentially just had you do is this thing called the vividness of visual imagery test, also known as the Aphantasia test, and it really highlights this more evolving understanding of the subjectiveness of human cognition and human visual imagery abilities. We've more and more discovered that this false assumption that we all experience spaces and cognize and perceive spaces and things in our environment the same way is sort of a false narrative that isn't really applicable anymore, that how you interact and see and experience and perceive and think about space is inherently subjective to your own being, and that we can begin to sort of tease out these differences in order to better understand and have a better understanding of the human experience and how we interact and think about things such as apples in our mind, but also maps. So this condition sort of came to a head or hit popular culture around 2020 when someone sort of tweeted out this old test that sort of dates back to all the way to 1970s, essentially that apple exercise. And sort of for the first time, the younger generation, or I guess the Twitter group, sort of realized that this subjectiveness in mental imagery sort of exists. People were realizing that what they have assumed for their entire lives as this equal ability to visually imagine something is highly subjective. Some people are super amazing and great at imagining things in their heads, while other people aren't so good, and maybe it's more vague, maybe they don't see anything at all, and perhaps some of you are in this room today. And this was even picked up by popular culture, by some news articles that sort of explored the topic more, but more importantly, it also revitalized this topic within psychology and aligned field, and it definitely got me interested in exploring this and thinking about what that meant for spatial and map cognition, and how I can use some of those theories and research to better our understanding of how we read, design, and use maps. So that condition, again, is called aphantasia, but what is it actually? If you look up the definition of aphantasia in the medical dictionary, or in this case, Google, it's usually defined as the inability to form mental images of objects that are not present. It's that ability to visually imagine something, right? Again, it's just that apple. And it's associated with this higher IQ individual And even recently, there's been newer research and debate on whether or not it can be a marker for people that are somehow on the autism spectrum disorder. And it's an evolving research, and we're learning more and more about it, but it also yields a lot of potential for map and spatial cognition, and it affects up to 5% of the global population, and that's like close to 400 million people. So we are beginning to understand that, okay, this is actually a very important domain, that it's not just a niche thing. We need to be able to better understand how these differences in our visual imagery ability actually affects people. Okay, so let's move on from just that theoretical apple. Now, what if I instead told you to think of a place, perhaps an apple orchard you went picking as a kid, or in this case, an apple orchard in Apple Park in Cupertino? How does that change? Because in the same way that we're thinking about that apple, you're also thinking about places, right? And really, it underscores this profoundness of how we experience and think about everything we do, whether it's visual information or topics of relevance or environments we interact with. It's that we sort of develop this mental model of our surroundings, of things we're experiencing, of things we're wanting to interact with in our head in order to navigate it. And it is through something called the cognitive maps. So in this example, we're quickly able to highlight what we do with the cognitive maps. Take this table, right? We might be able to look at the table, and we can recreate that model of a table within our head. But simultaneously, and that counts as perception, but simultaneously, we can also recall and simulate that model of the table, even though it's no longer present in reality. And we can build on that. We can also manipulate that model of the table and perhaps place an apple on top of it. But even more importantly, we're able to cycle our attention within what the model in our heads sees through our mind eyes versus what is actually in reality. But in aphantasic people, there's been studies that has explored how people that have aphantasia experience this a bit differently. In this study by Bainbridge from 2021, sort of explored how people, the control group versus aphantasia group, experience memory and perception. And what they did was gave them scenes for them to redraw in real time, highlighting their perception of these places, but then they took away that scene image and then asked them to redraw it from memory. And you can sort of see, comparing this control group versus aphantasia group, that details within the aphantasia group really decrease. There's things in here that they're just no longer capturing or unable to recall. This mirror that is no longer there. And it really just highlights that differences in experience and differences in cognitive ability for stuff that we've long taken for granted as the basis of spatial and also map cognition. So as a cognitive cartographer, researcher, that really got me thinking, because people in psychology are studying it generally, but what about cartographers? What about spatial cognition scientists? How does this ability affect how we navigate spaces, and how does it affect how we navigate and or use and read maps and also design maps? In order to understand that, we have to lean a little bit into something that is called the egotistical or ecocentric and allocentric spatial reference frame. And it really just describes how we sort of create that mental model of our spaces in our brain. Humans navigate through space through one of two perspectives. An egocentric way, which is seeing our environment in relation to us, comparing things in our surrounding to the ego, and using it to create sort of a bird's eye view mental map of the space that we can navigate through, versus an allocentric frame, which are spaces in relation to each other that are independent of the ego. So in a traditional sense, if you're here in Pittsburgh, as you're out navigating through space, you might try to think about a bird's eye view map of the area, and you might use that to explore in order to find your destination. And that's considered an egocentric navigational perspective versus an allocentric frame. Perhaps you're meeting colleagues at a coffee shop, and you know that you have to walk into a convenience store and turn right, and walk down into a factory and turn left. That is considered an allocentric frame. And really, all of this spatial reference frame and thinking and metacognition really underpins how we use and think about spaces, but it's also, more importantly, happening and occurring and planning in our head without us even really giving it a second thought. But the highlight of it is that what we understand of that through that, or how we've thought about that, is that it's wholly or primarily visual, right? We like to think about maps and spaces in these visual sense, almost as if maps are extension of that cognitive map in our mind, that we can recreate that mental space of mental models of spaces on paper, on digital display, as representation of that. But then how does this ability, how does this cognitive difference, aphantasia, affect our ability to read maps? What have the research actually say? Or does it at all, really? Because we can take that example of the table and we can lean in more and think about the differences when it comes to actually spaces. We can still perceive an environment and create that model in mind. We can recall that environment. We can manipulate representation of that environment, that reality, such as maps. But we also can cycle through this attention module whereby we're connecting what is essentially drawings, right? Maps are just points, lines, polygons, and create a whole environment within our head and able to connect the two. So that task is largely dependent, or understood to be dependent, on the ability to develop these mental models. So therefore, you would expect that aphantasics, people that have this lesser ability to visually imagine, would be bad at map cognition tasks, right? Well, it turns out that the jury is still very much out about that. I'll highlight this research from 2020. But in this research, they more or less found that when tested, aphantasic individuals did have a clear deficit, did suffer in terms of visual recall tasks, as in recreate the scene and point out things within it, or try to recreate it as closely as possible. But when asked to do spatial cognition tasks, such as map rotations or spatial rotation or locational recall, their performance is actually more marginal or more or less the same and isn't actually less than the control group. So that sort of like counters each other, right? How does someone have a reduced capacity to visually imagine, but still maintain a high degree of spatial cognition, something that we've thought about as being interlinked? And how can that degradation of visual imagery ability still somehow exist within a fully intact spatial cognitive space? That's more or less my frustration as I begin to set out to explore this, but also it gives me a lot of excitement as I'm building out this research agenda, because it flips much of what we know about map cognition itself on its head. We sort of operate under the assumption that map cognition is, again, largely dependent on that ability to manipulate those visual imagery, that visual models. And even my own prior research using fMRI have highlighted how when we give people maps and scan their brains, we see that your visual cortex lights up, which is in your occipital lobe. Your premotor cortex lights up, which is associated with two things: seeing things and planning your environment or planning your movements. Two things that has historically been associated with navigating through or imagery-based information, right? But if you look at the brain circuitry of people with aphantasia, we begin to see other regions that are lighting up in lieu of some of these activities that sort of spans the brain, and it sort of points towards a possible utility or utilization of an almost alternate circuit that isn't as reliant on that visual pathways. So it begins to point to this newer research domain that perhaps there's a way to think about and examine spatial cognition and map cognition that is beyond just the ocular-centric visual pathways, that we can begin to think about map cognition not through the visual senses, but through the spatiality itself. And what it really means is that there's a lot of growing unexplored research domain for me as I aim to establish a neuroscience of cartography research group within the UW CART Lab, and perhaps also you, if you're considering grad programs or want to collaborate and are interested about these topics, I would love to collaborate with you and begin to think about some of these profound spatial cognitive issues. And before I go, that's sort of like my research agenda. Or the future research agenda. If you're interested in sort of figuring out that ability for yourself, there's an online survey you can do that sort of tests. The link is up there, or you can get it afterwards. And with that, I'll conclude. Thank you.
I think we have time for a couple questions, and I see a hand right there. You had it up at the beginning. No, it's, yeah, sorry, go ahead. Yeah, sorry.
This is so interesting, Bill, and I have so many questions, but I think I'll go with this one, and that is, have you thought about how aphantasia would be able to feed into accessibility research in cartography, especially relative to
Yes.
vision or lower vision?
Yeah, yes, that's like one of the exciting domain about it, right? Like so much of accessible cartography research has been limited on this notion that like maps are inherently spatial and visual, that we are limited to just functioning in that paradigm, and that we need to find either not replacement, but substitution to establish those paradigms. But if we're able to better understand the circuitry that is independent of the visualness of it all, we can begin to better understand and hopefully design maps that are beyond ocular-centric, that are beyond these graphical representation, and begin to decode spatial information in new ways.
Super fun.